Hey guys, so today we're doing this problem which involves Green's theorem. The problem is, let f equal the vector of 2x plus y squared, comma x cubed. Evaluate the integral f ds where c is the boundary of the rectangle with corners at 1, 1, 3, 1, 3, 2, and 1, 2 transverse clockwise. Now we're able to use the Green's theorem, which is the easy way because it's a closed function because it's a rectangle and it doesn't cross over itself. So yay, we get to use the easy thing. So that means when we're setting up our integral, we don't have to do all of the extra stuff and we can just go ahead and set up an integral, and it's going to be a double integral because you have your y and your x. So it's clockwise and it's usually counterclockwise. So since it's clockwise, we're going negative. Okay, so we have our two integrals. So this is going to involve x and y bounds. So if you have trouble ever imagining your bounds, you can go ahead, draw a picture. So here's our y and here's our x. So we got 1, 1, 3, 1, 3, 2, and 1, 2, and you got your rectangle. Boop. So we're finding that, okay? And then there you go, just to help you imagine it more. There you go. So using this picture, you can easily find your bounds. So we'll do the x bound on the outside because that's just how I like to do it, but you can choose whatever you want. So it's going to be 1 to 3 for your first x bound. And then for the y bound, it'll be 1 to 2. Okay, so now that we've set up that, for the inside, we are going to do this first, the integral of this first with respect to x, integral of y with respect to x, okay? So the general rule of thumb, these are usually like you switch what one you're taking respect to depending on where it is. Okay, so you have the derivative of this, which is 3x squared. And then you subtract the derivative of this with respect to y. So that's going to be minus 2y. And same order of these, you got dy, dx. So there you go. You have this set up right here. Okay. So from then on, you just go ahead and you find your partial integrals. So first we're doing dy, so you still have your integral of 1 to 3 over here. Okay, so we add the y's, get 3x squared y minus y squared, because it would be 2 times 1/2 y squared, cancel that out, so just y squared. And then you gotta make sure to plug things in, so 1 to 2. And then you still have to take the integral eventually of dx, so dx right there at the end. Oh, don't forget your negative because it's clockwise. Okay, so now you go ahead, plug in your numbers. So that is going to be 6x squared minus 4, and then minus 3x squared minus 1. All of that dx. Okay, so I'm just going to simplify it so we can see it easier because, I don't know, live, laugh, love. 3x squared minus 3, okay, dx. Okay, now for the integral of that. So I'm going to leave the negative out front. And so this will be 3 times 1/3 x cubed. So the 3 and 1/3 cancel out just to give you x cubed minus 3x, and you gotta fill in your bounds. Okay, so now you just plug in your bounds, which gives you 3 to the 3rd, which is 27, minus 9, minus 1, minus 3. I'm gonna multiply all of that by negative once you get the answer. So that will give you 18 plus 2, which gives you negative 20. And that's your answer. So yeah, you got Green's theorem, which is this. You got your f of ds, and then you do the curl of all of this, and which will give you that. And then you just do your basic integral from then. Okay.